Look up at the night sky. What do you see? You see points of light, countless stars scattered across an endless black canvas. Each one is a distant sun, a powerhouse of energy. These stars define our universe. They have done so for billions of years, and they will continue to do so for trillions more. We live in a very special time, a time when the universe is filled with these brilliant, burning lights. This is not a forever state. It is a specific chapter in the grand story of the cosmos. It is an era of incredible activity and breathtaking beauty. Scientists call it the stelliferous era. The name comes from Latin. Stella means star, and ferris means bearing or carrying. So it is the star-bearing era. It is the age when stars dominate the universe. They are the main characters in the cosmic play. They are born from giant clouds of gas and dust. They live for millions or billions of years, shining brightly. And they die in spectacular fashion, seeding the universe with new materials. This cycle of birth, life, and death is what makes everything else possible. It is the engine of cosmic evolution. It began with the Big Bang, a moment of immense energy. The first few 100,000 years were dark. There were no stars. There were no galaxies. The universe was a hot, dense soup of particles. Then, slowly, gravity began to pull matter together. The first stars ignited. Where do stars come from? They are not just scattered randomly across the void. They are born in specific places. Vast, beautiful clouds of gas and dust. These are the stellar nurseries of the universe. Some are dark and dense, obscuring the light from stars behind them. Others are vibrant and colorful, glowing with the light of the young stars they have already formed. These colossal clouds are the raw materials for creation. They are mostly hydrogen, the simplest and most abundant element in the cosmos. But they also contain a sprinkling of dust and heavier elements, leftovers from previous generations of stars. Once a small pocket of gas within a nebula becomes dense enough, gravity takes over. The initial clump of gas and dust is called a Bok globule. As this clump pulls in more material, it starts to shrink, becoming denser and more compact. The core of the collapsing cloud starts to warm up. This warming, spinning core is called a protostar. Around the protostar, the remaining gas and dust flatten into a spinning disk. It's from this disk that planets, moons, and asteroids will eventually form. The entire system is spinning, a huge, spinning cosmic whirlpool with a glowing protostar at its heart. Eventually, the core of the protostar reaches a critical point. The temperature hits about 10 million degrees Celsius. At this incredible temperature, something magical happens. This is nuclear fusion. This energy pushes outwards from the core. This outward radiation pressure is now incredibly powerful. It finally becomes strong enough to balance the inward pull of gravity. The star stops contracting. This first flicker of fusion marks the birth of a T-Tauri star, a type of very young star. It blows away the remaining gas and dust from its cocoon with powerful stellar winds. For the first time, the newborn star is revealed to the universe, shining brightly in visible light. It emerges from its dusty nursery, a new beacon in the cosmic night. This is a moment of triumph, creating a self-sustaining nuclear furnace that will light up its corner of the galaxy for millions or even billions of years to come. With the start of nuclear fusion, the protostar has officially become a main sequence star. Our own sun is a main sequence star. This is the long, stable adulthood of a star's life. Deep within the fiery hearts of stars, new elements are forged. During the main sequence, a star is busy turning hydrogen into helium. Every other element on the periodic table was created inside a star. The carbon in your DNA, the oxygen you breathe, the iron in your blood, all of it is stardust. In the most massive stars, the core becomes a layered furnace like a cosmic onion. Each layer is fusing a different element. The element iron is the final stop for this process of stellar fusion. When the core becomes pure iron, the furnace goes out. Stars like our sun will puff away their outer layers to become white dwarfs over billions of years. The most massive stars are destined for a far more dramatic exit, a core collapse supernova. The explosion flings these newly created elements far out into space, enriching the interstellar medium. This material will eventually become part of the next generation of cosmic nurseries, providing the heavy elements necessary for rocky planets and life. The death of stars is not just an ending, it is actually a vital beginning. enriching the cosmos with heavy elements. Tiny grains of dust and ice, the legacy of long-dead stars, start to stick together. These pebbles continue to collide and merge, growing larger over millions of years. They become planetesimals. The largest planetesimals have the strongest gravitational pull, and they begin to sweep up the smaller objects in their path. In the inner, hotter parts of the disk, rocky protoplanets form from silicate dust and metals. In the outer, colder regions, icy giants can grow much larger by accumulating frozen gases. The result is a solar system, a star surrounded by a diverse collection of planets. We have discovered thousands of these exoplanets, worlds orbiting other suns. They are a wonderfully diverse collection. Among this amazing diversity, the ultimate prize is the search for a true Earth twin in the habitable zone. We are moving from a universe we thought was empty to one we now know is teeming with worlds. The Stelliferous era provides the essential ingredients for life. Life is based on complex chemistry, primarily involving carbon. Carbon is wonderfully versatile, creating the backbone of molecules like DNA and proteins. A main sequence star acts as a reliable cosmic power station, shining with steady light for billions of years. This provides the energy needed to power the chemistry of life. Without a star, a planet would be frozen and lifeless. The cosmic environment is relatively benign. The universe is a much calmer place than it was in its chaotic youth. This cosmic tranquility, combined with liquid water in the habitable zone, creates a perfect crucible for life. The Stelliferous era presents a remarkable convergence. It creates the heavy elements, builds the planets, and provides energy sources. It sets the stage perfectly for the emergence of biology from geology and chemistry. Given the sheer number of stars and planets, and the availability of all the right ingredients, the universe seems to be whispering a story of potential, suggesting that life may be a natural consequence of the age of stars. The Stelliferous era is filled with countless marvels. The most magnificent are the galaxies themselves. Within these galaxies we find star clusters, brilliant jewels on the black velvet of space. The era is defined by its nebulae, ethereal clouds that are both birthplaces and graveyards of stars. These clouds are the paint and canvas of the cosmos, creating scenes of unimaginable beauty. All good things must come to an end. The Stelliferous era will not last forever. Its end will be a slow, gradual fade. As larger stars burn out, the cosmic stage will be left to the red dwarfs. These small, cool stars sip their fuel with incredible efficiency. The universe will enter a prolonged twilight, a red dwarf era lasting for trillions of years. Around 100 trillion years after the Big Bang, the very last star will finally flicker and die. The Stelliferous era will be over. The universe will enter the degenerate era, populated by the corpses of once mighty stars. Eventually, even black holes will evaporate. The cosmos will be a cold, dark, near-perfect vacuum, the ultimate fade to black. We have journeyed across trillions of years and countless light years, witnessing the grand story of the Stelliferous era. Look at your hand. Every atom in it was forged in the heart of a star that lived and died long before the sun was born. You are, in the most literal sense, stardust. You are a child of the cosmos, a direct product of stellar life and death. We are not merely observers of the universe, we are a way for the universe to be aware of itself. We live in the cosmic morning of the Stelliferous era, a vibrant epoch when the universe is alive with light and potential. We are fortunate to be here, on this small blue world, with the capacity to understand the story that surrounds us. This knowledge connects us to everything. It gives us a perspective that transcends our daily lives. So the next time you look up at the night sky, remember this journey. See the stars as cosmic ancestors that made your existence possible. We are temporary residents of a magnificent cosmic cathedral built from the fires of creation. The universe is telling its story, and for a fleeting moment, we are here to listen.